I'm Joel Rutherford, and this is the concrete lesson for the Building Sciences program here at Muscle Shoals Career Academy. As always, there will be a worksheet / quiz that will accompany this lesson. Make sure that you complete that. Also, as you work your way through this presentation, you need to be taking some notes so that you will have something to study for when we get ready to take our test. So having said that, let's just jump right in. Concrete is a very versatile building material. Pretty much the sky's the limit. This is a good example of some innovative concrete construction. You can see the curves and just the detail that's been accomplished with a material like concrete. Now, concrete is just a mixture of 4 ingredients. It's fine aggregate, which most of the time is sand, coarse aggregate, which is usually some form of gravel. It may be small gravel or it may be larger gravel, Portland cement, and water. Now, when these 4 ingredients are mixed, there's a chemical reaction that takes place, and it's called hydration. And that chemical reaction is what causes concrete to harden. Concrete doesn't dry out. When it gets hard because of a chemical reaction. Microscopic crystals are formed that bond the aggregates, the water, and the cement together, and that's what makes it get hard. Now, concrete, within a few hours of mixing concrete, it will get hard enough that you can walk on it. That's how driveways are put in. If you've ever seen a driveway finished out, you'll know that the concrete finishers will pour it in the morning, and by that afternoon they'll be walking on it, finishing it up. And even though it's hard, that doesn't mean it's reached what we call the design to strength. And the design strength is the strength that it was mixed for. You can get 3,000 pound concrete mix, which means it'll hold 3,000 pounds per square inch, and it can go way on up to 20 and 30,000. But it takes quite some time for concrete to reach its design strength. Takes about 28 days. So keep that in mind. And just as a general note, if you sidewalk, let's talk just a little bit more about the ingredients of concrete. Portland cement is probably the most important ingredient, because when mixed with water, Portland is the ingredient that causes the chemical reaction hydration. Portland cement is just a finely ground powder made up of lime, silica, aluminum, and iron. Coarse aggregate, that's usually gravel or rock. Fine aggregate is sand. And water, it needs to be clean water to have a good strong concrete mix. Aggregates are mostly just filler. They make up 75% of the volume of concrete, and they're just there to take up space mostly. The main 2 ingredients are the Portland cement and the water. Okay, this is an example of cement dermatitis, and this is it's a pretty gruesome injury here. This is someone, it looks like to me, has walked around in plastic concrete with a pair of tennis shoes on, and probably allowed that concrete to get up over their tennis shoes, and it's burned their skin. And this is a serious condition. So if you are ever around concrete and you get some on you, go ahead and get that off. It's not a situation where you have got, if you get some on your hand or your body, you don't have to run that very second to wash it off, but I wouldn't wait too long. It takes a while for the concrete to set up and to burn you, but I wouldn't wait too long. And one of the things that has been a focus of the Occupational Safety and Health Administration lately is a lung disease called silicosis, and that is just, when you breathe in cement dust, you're breathing in silica, and over time silica can reduce your lungs capacity to take in oxygen. So it's very serious. There's a lot of new standards out there, OSHA standards that is, related to silica. So be careful that you are not breathing in cement dust. There are several types of admixtures that can be added to concrete, and these are just materials that change the characteristics of the concrete. One of these is an accelerator. An accelerator will make your concrete cure more quickly. The common name for this is calcium. If I were to order concrete to pour a footing or a driveway or anything today, and I asked them to put calcium in the concrete, it's going to cure a lot quicker. And mostly this is used in wet, cold weather, because in wet, cold weather, concrete is slow to set up. So we add calcium to it, and that helps it to set up more quickly. A retarder slows down the curing process. So we might put some retarder in there if we were finishing concrete in a hot and dry environment. And finally, plasticizers. Plasticizers will improve the workability, and the way they do that is by charging all of the molecules that are in a concrete mixture with like charges so that they repel one another, and this really allows the concrete mixture to flow and move easily. I will post in the Edmodo lesson that we are looking at right now a video concerning super plasticizers. Okay, there are a few special types of concrete. One is a high strength or high performance concrete. High performance concrete has a design strength of 6,000 psi or more. A lot of times this is used on bridges and overpasses, and remember that the design strength is the strength that the concrete reaches after 28 days. This is an example of roller compacted concrete. This type of concrete is used for large areas. They don't have a lot of reinforcing in them. The mixture is dry and stiff. You don't use forms when you're putting down roller compacted concrete. It's spread with bulldozers and pavers. And again, when you watch your YouTube video, there will be a when you complete the Edmodo lesson, I will insert a video there so you can see an example of roller compacted concrete. Lightweight concrete. You can see this building here has been constructed with lightweight concrete. There's less need for structural reinforcement. It's lighter, so the foundation requirements are smaller. It's more fire resistant, and it can be used as an insulative material. Now, here's another way, is a curing method, curing compound. Curing compounds form a waterproof barrier over the surface of the concrete, and this just keeps the moisture from escaping the concrete. You can see this gentleman's just spraying this, and most of the time it's called cure and seal, and it just seals that concrete up so that the moisture can't escape. It stays down in that concrete slab and allows hydration to progress. Placing down curing paper or even plastic sheathing works much the same as using a curing compound. All we're doing is just keeping the moisture in the concrete itself rather than allowing it to evaporate into the atmosphere. Okay, a slump test is used to determine the consistency of concrete. The more water that's in the concrete, the greater the slump. The greater the slump of the concrete in most conditions means that we will have weaker concrete when it's cured. This is something that's very important and it's very common on construction sites. I'll encourage you highly to watch the Edmodo video link that explains how a slump test is done. Now we're going to talk just a little bit about concrete reinforcing. Concrete is very strong in compression, so if we are just putting weight on concrete with a strong sub-base under it, it's going to really hold up to a lot of weight. Where concrete is weak is in tension. So if you look at this little picture here and imagine the forces in this when we have a concrete beam that's supported on the left and the right side and it has a load coming down in the middle, you'll see that the bottom half of this concrete beam is sort of being stretched. So it's in tension. The top half here is being squeezed, so it's in compression. Concrete does well when it's in compression. Tension is where concrete is weak. So to counteract that tensile weakness, what has to happen is steel bars are placed into the lower half of concrete beams or slabs, and that helps to counteract that weakness in tension because steel is very strong in tension. So these two materials work together to make a stronger concrete system. Now remember, as we just discussed, the concrete is in tension in the bottom portion of the beam, so that's where the steel has got to be. If you are ever working on a concrete slab and you put the steel in the top part of the footing, you've wasted your money. The steel does nothing if it's in the top part of the footing or slab. The steel has to be in the bottom part of the slab or beam. Steel is used for concrete reinforcing because it has the same expansion and contraction rate as concrete. That's very important. When the temperature rises or falls, concrete and steel both expand and contract equally. If one of these materials had a expansion or contraction rate different than the other, then we wouldn't be able to combine the two materials. Sometimes steel fibers are mixed into concrete to supply the reinforcing. Fiberglass is sometimes put into the reinforcing as well. Sometimes rebar is called re-rod. You probably need to remember that for your test and also going forward in your careers. The ridges on concrete, the ridges on rebar are there for a reason. And the reason is they improve the mechanical bond between the concrete and the reinforcing. So that strengthens that bond there. Sometimes though, There are situations where smooth bars are used, and these are mostly where we have expansion and expansion joints. If we have a piece of rebar that is spanning an expansion joint, we will usually make it smooth. Rebar's named with numbers. The numbers tell the size of the bar in eighths. So for example, a number 3 rebar would have a diameter of 3/8. A number 5 rebar has a diameter of 5/8. A number 8 rebar has a diameter of 1 inch, 8/8. And one thing that you may not realize is that the rust that forms on rebar actually helps it to bond better to the concrete. So you might say that, rain. This is an example of some bar supports, and these would be placed in the bottom of a slab or some other kind of concrete structure. And what they do is they hold that rebar up off of the bottom of that form. Remember, we talked about the rebar has got to be in the bottom part of a slab or beam. It's got to be in the bottom, but it can't be laying on the very bottom. So it needs to be about 2 to 3 inches above the bottom of whatever it's in to do any good. And these bar supports help that to happen. This is an example of a rebar mat and some other structures here that are being put together. Welded wire fabric is something that's used in pavement and parking lots or other flat work. It doesn't really keep the concrete from cracking, but it keeps the cracks from spreading. It's called sometimes WWM. That may be what you see on a set of drawings, and WWM stands for welded wire mesh. Rebar can be dangerous. This is a picture that was of a test that was done by some steel workers, and what they did is they took a bag and filled it with sand, and from a height of whatever, they dropped it down onto this rebar. So you can imagine what that would do to a person if they fell onto the rebar. And if you look, this rebar is turned to the side, and it still broke through this sandbag. So rebar can be very dangerous. We need to be careful when we're working on a job that has rebar, especially if it's below us. And that even applies if we just have rebar that we've driven into the ground and it's just sticking up a few inches. If a person were to fall onto a piece of rebar that is just sticking up out of the ground a few inches, it would impale them. So it can be very dangerous. One of the ways that we try to minimize the danger of rebar is by placing rebar caps on top. And if you look at these orange caps here, these are just placed right on top of the rebar, and that helps to make it a little more safe. Another hazard that's present on job sites is rebar that may be sticking out horizontally. It could, if it's head high and it doesn't have a cap of some sort on it, and someone were to run into that, bump their head on it without a hard hat, it could really mess that person up. So rebar caps are very important to use. Let's talk a little bit about concrete footings. This is an example of a continuous footing here. And sometimes these are called spread footings. These are usually used to support poured concrete walls or even concrete block foundation walls. This is an example of a footing form, and this is on your test. Make sure that you've got this down, and in particular I want you to pay attention to this spreader cleat, and also know that these bars sticking up here are rebars. Now this is showing a trench footing. These are the types of footings that are used around North Alabama. We are blessed with really good soil for building and construction, so we're able to just get a backhoe like in this slide and dig a trench. You can see they put the re-rod here in the bottom of this trench, and then over here they've just poured the concrete, and it'll set up, and that's our footing. If you get somewhere down around the Gulf Coast where the soil is much more sandy, then trench footings are not really something that you can use. You've got to use pier footings down there. Out in Texas, the soil is called caliche, so they have a different type of soil out there, so they do different types of footings. And I guess the point of that is that in different geographical areas. Okay, this is a picture of a pier. You can see we've got a footing here, and in this case we just have a poured concrete column. That column could also be made out of concrete blocks, so that would be a type of pier footing. They're isolated, they're set in soil, and they just support posts, columns, beams, and girders. This is a wall form section. Now these types of footings are very common in commercial construction. And I have actually all of the materials that are needed to construct one of these, so if any of my students are interested in learning how to build one of these wall forms, please let me know, and I can set you up and teach you how to do this. I even have an instructional video on my website that can give you some pointers on how to construct one of these. Okay, a little bit more about concrete forms and footings. The studs are upright members that support the sheathing, and the sheathing is panels, sort of like plywood, and that's what gives the wall its shape and texture. A lot of times the type of sheathing that's used is called ply form. Ply form is easier to remove than regular sheathing, and sometimes we'll even treat the sheathing with oil to help it release a little more easily. Wailers are the horizontal members used to support the form and the studs. So if you go back a couple of slides and look at that wall form picture, you will see the wailers. You will also see the strongbacks. The strongbacks are upright members that support and stiffen the form. We use form ties and spreaders, and also braces when we start constructing concrete wall form. This is another example of a slab form here. If you make a note of the scab here, that's going to be pretty important to know. And you can see these guys here have poured a slab down here, and you can see this is looks like it's on the Gulf Coast, and it's just the form goes right around where we want the slab to be, and then we pour concrete in there. When the concrete is cured, then we will wreck the forms and come back and start the construction of our building here. This is an example of a monolithic slab, and a monolithic slab is basically just when we pour the footing and the slab all as one. So it's all together there. As you go forward in your career, if you are ever going to take down the concrete forms, especially on a commercial job, make sure that the engineer on the job is given their approval. Uh, Small time residential construction. That's the end. That's the end of our concrete discussion. I hope you've learned something from it. I hope you have taken good notes so you'll have something to study for your test with. If you have any questions, please ask me. But outside of that, thank you very much. I hope you've learned something, and I hope you've enjoyed this instructional video.